Greetings, humans have adapted to living on this planet, and as a result, we have evolved with specific characteristics. However, these traits could be very different on other planets. Can you imagine how we would be if our species had evolved on a different world? How different would we be? On Mars, one of our closest neighbors, our species would be entirely distinct, even our history would differ. The potential changes that humans born on Mars might undergo could surprise you. I'll begin by making Mars habitable and allowing life to thrive on a planet so different from Earth. Its potential history, biological features, and even its view of the universe. In our solar system, Earth is at an ideal distance with a pleasant temperature. Life emerged about 4 billion years ago. Let's go back in time, precisely 4 billion years ago, when Mars had oceans of liquid water and a dense atmosphere. However, this state didn't last long. Mars lacks a significant magnetic field, and as a result, the solar wind gradually stripped away its atmosphere. Let's provide the planet with a magnetic field by giving it a dynamic iron core. Mars is still too cold, with a primitive atmosphere of nitrogen and carbon dioxide. Temperatures remain below freezing in many places. We'll increase the sun's radius and turn it into a Type F star, with a temperature slightly over 6,000 degrees Celsius. Mars warms up, the water cycle begins, clouds form, and rain falls. Nevertheless, life does not appear. The orbit is too eccentric. Unlike Earth, summers are much hotter, and winters are much colder. We'll make that orbit more circular to stabilize the climate. We'll stabilize the climate by bombarding the planet with space objects. We'll provide the organic components and essential amino acids to kickstart the combination and evolution of life's molecules. Initially, unicellular organisms, multicellular life, microbes, and bacteria that produce the oxygen lacking in the Martian atmosphere must form. But to have humans, we need much more: an ozone layer to shield the planet from ultraviolet radiation. Plants develop, animals evolve on solid ground, and more oxygen accumulates. It's astonishing how much we humans depend on other life forms to evolve. What I'll tell you now are hypotheses based on scientific knowledge. A Mars with a dense atmosphere and liquid water would be something like this. A constantly renewing atmosphere that prevents loss into space would be necessary. This would mean many more forests and microorganisms. Oxygen levels would be at least 30%, similar to Earth's Carboniferous period, with gigantic creatures. There would be more lightning storms, and fire would be discovered much earlier. There wouldn't be vast oceans isolated from other continents, and human civilizations wouldn't remain isolated, evolving independently in various places around the globe. This means that, for instance, the Chinese wouldn't be hidden behind the Himalayan range for thousands of years, and Native Americans wouldn't be separated by vast oceans from the rest of the world. This implies that human evolution on a smaller planet would be faster, resulting in less diversity. The lower gravity would lead to earlier development of flight technology and, consequently, space rockets. Furthermore, on a smaller planet, there would be a greater need to explore space sooner. We'd achieve space travel thousands of years earlier than on Earth. Humans would resemble each other much more than they do now. There wouldn't be significant differences among different races, although we would be much taller, averaging over 2 meters, with thinner bones and less muscle mass, smaller feet, bodies adapted to 1/3 gravity. When observing Earth, Martians would see a desert world devoid of water and life, with a dense carbon dioxide atmosphere at over 400 degrees Celsius due to the greenhouse effect. We might wonder whether life could exist on a planet twice the size of Mars. We'd likely think that a large moon like Earth's could disrupt a planet's atmosphere and cause massive tides, preventing the evolution of life. For us Martians, a planet with an asteroid moon and a stable axis would be more typical. When observing the universe, we'd focus on finding yellow-white F-type stars and habitable planets similar in size to Mars. We'd consider this star type and planet size to be the ideal and standard for habitability. Mars, for us, would be the perfect life incubator. Our view of the universe as Martians would be vastly different from the present. If a Martian were to observe present-day Earthlings, they would find a diverse array of races and cultures, sturdy but slow dwarfs. However, it's unlikely that there are two planets with intelligent life in our system, though not impossible. When we tailor the sun and conditions for one planet to support life, the other would suffer consequences. This can give us an idea of how different life on other worlds could be based on their planets. On the other hand, if we were to relocate as settlers to the current dry and radioactive Mars, the situation would differ greatly from natural evolution on a habitable planet. A body adapted to Earth would need to change significantly to withstand Mars' hostile environment. If we were to establish cities on Mars one day, humans would gradually lose bone mass and become paler, weaker, and more prone to illness. Evolution would correct these deficiencies over a few generations. The bones of future colonists would eventually become thicker, resulting in a more robust appearance. Over time, we become taller, with elongated noses to adapt to Martian radiation, climate factors, and solar storms. We produce more melanin, resulting in darker skin. On Earth, a baby is born with at least 60 genetic mutations. On Mars, around 1,000 would be necessary to adapt to the prevailing conditions, leading to faster evolution. It's believed that within just 6,000 years, we'd have humans with biology suited to living on Mars. Without Martian microorganisms, colonists would gradually lose their immune systems and become isolated from Earth's inhabitants. Crossbreeding with Earthlings or contact with them could be lethal for Martians, as they become contaminated and exposed to diseases from Earth that Martian colonists couldn't combat. Furthermore, Mars-born colonists couldn't travel to Earth, as it would be extremely detrimental. The climate and gravity on Earth would be unbearable for Martians, who would be incapable of functioning on the planet. We would become a distinct species from Earth's inhabitants in just a few generations, leading to Martians developing their own culture and laws. In the conquest of more planets across the galaxy, we might encounter extraterrestrial humans adapted to each planet, with different biology and cultures. There are already many differences among races on our planet, with civilizations isolated from the rest for millennia. So, imagine how different we could be on Mars or other worlds in a few generations. In many films, we see Earthlings and extraterrestrials freely roaming planets without protective gear, even interacting. In reality, this is much more complicated than it seems. The biology of any living being is delicate and uniquely adapted to each planet. This is why I believe a widespread planetary conquest would likely require machines or cyborgs, although this would also be limited by resources. And assuming that 2 planets with intelligent life were possible in our solar system, the Martians would be much more advanced than us. And if they wanted to invade us to live here, they would have a tough time. A terrestrial would move much more effectively on their home planet. So, Martians would avoid leaving their ships and engaging in close combat with us. Although they would be taller than us, they would be extremely slow in an environment with gravity 3 times stronger than that of Mars. This would mean we could easily knock them down with a simple pat, and they would have to rely on their more advanced technology. However, I highly doubt they would stay. It would only be to gather resources and leave as soon as possible. Therefore, a global-scale invasion wouldn't make sense. If it were the other way around, and we Earthlings invaded Mars or gathered resources from it, then our biology would be at a disadvantage on their planet. That's why I believe that civilizations across the universe could temporarily settle on a planet within a solar system, gather what they can, and then depart. Finding an ideal planet for each species to establish a colony isn't easy. It's possible to envision 2 habitable planets in a single solar system, each with differently evolved civilizations. This is a scenario that scientists consider plausible, as if life were to emerge on a suitable planet and another one existed within the same parent star that met the necessary conditions, it could spread through panspermia. However, the leap from single-celled organisms to advanced civilizations would be vast. Likely, on one planet, intelligent life would have evolved with space travel capabilities, while the other might still be in prehistoric times or only have microscopic life. Therefore, they wouldn't be able to communicate. Perhaps in some solar systems, the unusual circumstance arises where 2 planets of the same solar system evolve simultaneously. What's evident is that one species would be more advanced than the other, and perhaps the only interaction between them would be based on peaceful trade that benefits both. If you enjoyed this video, please like and subscribe, share on social media, and leave your comments.